Hello everyone, my name is James Pruitt. This is my 8th lecture on JavaScript. We're still working on a large integer type. And before we get back to the program we were working on last time, I want to talk about the switch and the syntax of the switch. So switch is switch is it can be used in place of if you do a sequence of if else else ifs, if else if else if. So you can make you can select one of a group of options. Um, so it's the standard. The syntax comes from C, but it's not. It's more powerful than C's switch statement. So you'll have something that looks like this: case expression two, semicolon statements, break, then we have case expression 3. You can have as many case statements as you want. Uh, and then break, and then we'll have a default. And the default is optional. You don't have to have a default statement. And the default statements can go anywhere, but we'll talk about them in a second. And then we'll have a closing brace. So what an expression is anything that evaluates to a value. So this expression evaluates to a value, this expression evaluates to a value, and then what switch does is it compares. If they're equal, and it uses this equal sign. And like we said, there's two types of equalities. This equal sign uses typecasting if it's possible to cast one type into another. This equal sign doesn't use typecasting. So we're not, it compares with this. So this evaluates to a value, this evaluates to the value. If they're equal according to this equal sign, it will start executing these statements. The break here is optional. If you don't use the break, it's going to continue down and execute these statements. The break will jump to right past this curly brace. And if this value from this expression is equal to this value from this expression, um, um, then it won't execute this expression. So this expression only gets executed if this one fails, if this value fails, and it goes in a sequence. And default can go anywhere here. It makes no sense to me to put it anywhere else but at the end, but you can put it at the top or here, anywhere you want. And if none of these expressions match, the default will execute. And these values, these expressions can evaluate to any values. Okay, that's it for the switch statement. Let's go back to our program. And we said, right, let me go ahead and move this up here so I can keep track of time. And then pull up my code. So we did, well, where were we at? We have this initializer. We're doing a construction. We're doing this closure where we have this environment model where we can store our variables where nobody can get it but the function that I'm going to pass out of this function. So integer input initializer, and initializer is we're going to use to construct. This number is an array, this negative is a boolean, and if it's true, it's negative, if it's false, it's positive. These are just temporary variables, and they're not going to stick, well, I'm not going to use them for anything except for computation. They're not going to be count as state for my integer. And my radix is the 2 raised to the 26th power. And what we did, we looked at the type of the initializer, and this type of operator will return a string describing what the initializer is. Is it a number? If it is, then we use this code. If it's a string, then we do this code. And we've talked about that the last 2 times. Now we're coming down to the object. And what I'm testing for, let me come back over here. And I have my principal, my tautology that I said that, let's see, something's not working right. Okay. And I said my tautology, let's see if I can spell that. is that I'm going by, the principle is efficiency. Efficiency is important when it is important. And basically that means is I'm not going to think about efficiency until I'm running my program, and if its efficiency is affecting my experience with the program. I'm going to ask the program to do things. If I have to wait too long, then I have to worry about efficiency. I don't worry about efficiency until my program is not running fast enough. And I won't know that until I actually run my program. And if it's so slow that I have to go back and think about how to do things. But the most important thing is that it runs. So we're not going to worry about efficiency until the program's so slow and we can see it being slow. But if we run the program and it runs fine, we don't care about efficiency. Again, we know the algorithms that are fast, and we know, so we'll pick probably if we had to sort something, we'd go with merge sort or quick sort before we'd pick insertion sort or bubble sort. So we have our knowledge, but we're not going to worry about it. So the thing, what I'm trying to make a point here, I'm doing a lot of type checking that might slow us down. So we have this object. If our initializer is an object, and we'll come back here. So we said we're going to have, the initializer is going to look like something like this: number when it's an object, number, and we can say A0, A1, A2. I don't know why I like A3. And we know that the number, this is A3 times 2 to the 26 cubed, A2 plus A2 times 2 to the 26 squared, plus A1 times 2 to the 26 plus A0. That's how we have our number. And then we're going to have this negative, and that's going to equal to false. So something like that. And we can see that that's what an object is. And we can come up to our program, and we can test that type of number. This is the constructor for an object. And what did we say? We said we'll just go 1, 2, 3, 4, and then we'll go to negative, and then we'll say that's false, and then we can and that's going to be an object. You can see that's what an object is, and that's what we expect our object to be. And this is going to be input by our algorithms, our multiplication algorithms, our addition algorithms. It's going to generate these numbers, and this is what we expect to see when we get to this far. So basically, we want to double check that everything's a-okay. As much type checking, and that's where it might slow us down, but we'll worry about that if we have to worry about that. So the first thing we'll check is if negative is a Boolean. Initializer.negative, this property is a Boolean. If it's not a Boolean, we throw an arrow. Okay, then we'll check if initializer.number.length is undefined. So we can come right here and we can say, for instance, type, let's go ahead and say x is equal to, boom. And so type of x, and that's going to give us an object, and we can say x dot number dot length, and that's going to be, or let's see, let's see what that's, it might not give us number dot length, and okay, let's see, print x dot number undefined. So this might, let's see where we're back over here. So we got initializer.number.length, and it's going to throw an error if number is not defined. And then I'm checking length against undefined. So like my Rhino threw an exception just because number, I'm trying to access undefined. Undefined is not an object, so I can't use the selection operator, if that's what it's called. I can't remember what that's called. A selection operator on an undefined value. So if number is not defined, or number is not a property of initializer, this is going to JavaScript's going to throw its own exception. But here I checking to make sure that length exists. So that means that number is either an array or a string. And then I check that the length of number is 0. Uh, uh, and if it's 0, I want to throw an exception because I want a 0 is going to have at least length 1. So all my array length should be at least 1. Okay, so I come down here and go ahead and put whatever negative is equal to initializer.negative. Okay, and then I go through each of the numbers, each of my digits, and I check that my digit initializer.number I is not equal to number. And then I come in here and initialize, and if it's not equal to a number, then I throw an error. Then I check if it's negative, I throw an error because my negative, I have a separate Boolean value for negative. And then I check for that it's greater than the radix. If it's greater than the radix, I want it to be less than the radix because that's how digits are. So I also want to check, and I didn't, number I is not equal to, let's see, if it's not equal to math.floor initializer.number I. Okay, so what I want to make sure it's not a decimal value. Let's go ahead and save that. And so we come back here. Okay, so we've checked to make sure it's not a decimal. It's the radix is between 0 and it's greater than or equal to 0, less than the radix. It's a number. Okay, so we did all that check. Once we check that value, we can go ahead and store number into initializer.number. Okay, now we've almost done. Now we check just for our own sake. Initializer.number.length is greater than 1. If it's greater than 1, then the most significant digit can't be 0. If you have 2 digits, I don't want the most significant digit to be 0. So I want to keep that length to the proper length, so for my algorithms to work out right. So if that's true, if the most significant digit is 0 and the length is greater than 1, okay, 1 digit can be 0, but it can't be 0, 1. So I'll throw an error, and that's it for that. And if it comes out anything besides a number, a string, or an object, go to the default. And if initializer is equal to undefined, that means I didn't put anything in. I didn't pass a value to this the integer. I'm just going to set number equal to 0, and I already have negative. The default negative defaults to false. So that's it for our constructor. Now we want to come down here. This is just a helper function. We'll come over that. Now we want to look at what messages. I'm viewing this as you pass messages to the integer and it passes out information. So we're going to look at the messages next time. And the hard part is how to convert our number to a string. And that's where this helper function divide by 10 comes into place. And then we're almost done. Not much longer. Okay. Talk to you on the next lecture.